Okay, so last time we talked about like rational points on the circle, but we can use sort of those same methods for similar conics. So in particular, we're going to look at rational points on x squared plus ny squared equals 1. Um, okay, and so let's see what that looks like. Looks kind of like this, probably. And those are our axes. And so we can sort of use the same methods we use for the circle. So we can immediately see that one of the solutions is negative 1, 0. And we pick negative because it's more convenient for our slope. So that's over here. And then like before, we want to draw the line L, and this is going to be another point. And this might be 0t, and we know we want this point to be rational, and so if our line has a rational slope, and then this point will be rational, and there'll be another point on the conic, because our conic it's a quadratic with rational coefficients. Okay, so then we can find the equation of this line L the same way we did before. Y equals t times 1 plus x, where t is the slope, right? Because the slope m is like t minus 0 over 0 minus negative 1 if I use these 2 points, which is just t. And then if I use point slope form, I get this equation. So then we can just plug this in, right? We have two equations, so we can plug this in. And we get x squared plus n t squared times 1 plus x squared equals 1. Now, even though we want to solve for x, we're going to move the x squared over. And we get that. And now we know that negative 1 is a solution. So we can, like for fixed t, this is a quadratic in x. And so we can factor out the solution x equals negative 1, which is like x plus 1 equals 0. So we can factor that out. And then we get 1 plus x equals 1 minus x. And so now we can solve for x, right? So we have nt squared plus nt squared x equals 1 minus x. So x times nt squared plus 1 equals 1 minus nt squared. So x equals 1 minus nt squared over 1 plus nt squared. And you notice that when n equals 1, we have the unit circle, and we get the familiar parameterization of 1 minus t squared over 1 plus t squared. Okay, so then all that's left is to figure out what y is. So if we solve for y, we have y as t times 1 plus x, which is t times 1 plus t squared over 1 plus t squared, that's our 1, plus 1 minus t squared. Alright, I'm using the n equals 1. We don't want to forget our n. So there's an n here, an n there, n there, n there. And then you get, well, these nt squared and minus nt squared cancel out. So you get 2t on the top and 1 plus nt squared on the bottom. So we have finally, these are our solutions. And so you can see that we have t equals y over 1 plus x. So if x and y are rational, t is rational. And similarly, if t is rational, x and y are rational. So, and t defines the slope. So if you pick a line with rational slope, intersects through, you have a way to parameterize the rational solutions x and y. Just pick rational t's. And there's infinitely many t's to pick, so you'll have infinitely many solutions.